I hope the entire end-to-end workflow is clear, where we have seen that why full table scan in this specific case, why it becomes the entry point for our query analysis. And once we have the full table scan, then whatever the number of records we get, how it gets iterated through and then joins with the other table or follow-up tables. In this case it is a customer table. Why it is performing the unique key lookup, we have seen that as well. Why this one row and what is this number, and how this final outcome number gets added here, we have understood this part as well. Now moving to the next, on performing this scan on this specific record, why this 3k rows is getting resulted as a output, right? Again, why this non-unique key lookup, what is this 9 row or from where it is coming up, right? We have seen all these things as well, and same logic is getting applied here as well. Now our next part is, if you make some tweaking on the indexing and if we rerun the explain statement, we'll see the explain statement output behavior. I'm expecting the output behavior to be changed because we are going to play with the indexing, and since we are not modifying the query, so whatever the query we have, it is going to evaluate based on the latest indexing, and based on that it should change the explain statement behavior, right, as output. So let's see that. So first we will try on the customer table. So now if I go to customer table, so let me open the customer structure, and what I'll do is I'll go to index, and here what I'll do is I'll change the primary key index from customer number. I'll keep this customer number as a primary key, as well as I add the, let's say, customer name as well. Anyway we are experimenting it, right? So I'll make this as a composite primary key. So basically customer number with customer name, this two combination should identify the records uniquely in the database. And I'll keep the setting, I'll keep the database set as it is. Okay, I'm not going to change that, right? Now I have made this change. Now let's go and analyze this again. So simply click anywhere in this statement and then click on explain current statement. So before I run this, our output should get changed, and from performing non-unique key lookup to it should change from non-unique key, sorry, it should change from unique key lookup to non-unique key lookup, right? So let's rerun this, and if I switch to the visual explain, see, it got changed from non-unique key lookup, but still it has only one row. Why? Because in this 326 row, right, whatever the customer number we have, it is still able to identify the row uniquely. Hence it is showing one row, but the scan type had changed from non-unique, sorry, unique key to non-unique key. Okay, and if you mouse over on this, now access type, if you see, change from equal reference to reference, right, EQREF to REF, right? Same thing again if you revert this. So let's revert this and make the changes on product table. So I'll revert this and I'll make the changes on product table. So I'll say product code and product name. I'll apply this change, and now if I rerun this again, I'll be expecting the output like non-unique. This should change from non-unique key to unique key, and this should change from unique key to non-unique key. So let's rerun this. See, right? And this is what we were expecting. And if you look at here, right, see, the query cost has changed here, right? Because here it was iterating over only on 326 records, but here it is getting evaluated on 2996 records, which is almost 3000 records, and hence query cost got increased from I think 1000 something to 2500, and overall cost was like 1517 to 3077.12, right? And you can see this, like this is a very simple query with a very simple use case with very less volume of data. And just by changing the indexing column, right, how it is impacting the query performance. Now imagine a case which we were discussing earlier, right, in the beginning of the session, like what would be the use case. Now imagine a case where you are dealing with a complex report, where you have a complex query, right? And if you're facing some performance issue on that, and if you analyze this, you will see exactly this sort of output, and it will clearly tell you where your cost is getting increased. And that's why I love this tool. I love this explain statement, because it gives me an immense number of information which I can make use of it to improve my query, right? So again, if I change this, like indexing from, let's say I'll remove this composite key index, I'll keep only on the product table, and if I rerun this, now I'm sure you guys have understood the flavor. See, it's like again same thing. Okay, all right. Okay, now you may ask, okay, why it is still showing the 2556 row? Because we indexing may take some time, right? So we'll have to give some time to the database. Coming back to the original use case, right? So this is what we had initially planned, and we have successfully seen that as a result, right? Where we talked about one of the use cases and how that has the impact on the uh, query performance. We have seen that as well. If you look at the documentation, right, I have mentioned the ways of executing the explain statement. I have basically attached the screenshot, like how to execute from the workbench, and then all the possible options that you can see it here, right? Now let's deep dive into the tabular explain plan output format type. Okay, although we have discussed most of these points, but let's see what are the other columns we have and what roles they are playing in terms of understanding the analysis output, right? So for that, I would like to go to the query, and I would like to rerun this. Okay, see, now the query cost has started decreasing, right? As I told you, uh, since we have like made some changes to the indexing, so the original state over the index table space had changed for that specific entity. Now it has to, it has, in the sense, database has to again index the data based on the available indexing or available indexes. And once that index is ready, then we can start seeing the impact on the scan result, on the analysis result using the expand statement, right? So as I said, if you look at the the cost has suddenly down from 4,000 something to 2,000, right? Okay, fine. Now let's switch to the tabular explain and see what all columns we have. So it says like id is fine, id is like 1 1. Select type, so it's a simple select type. And what is the table? So table is like, it says OC, OD and P. Basically these are the table aliases that I have used here. So if you don't want to confuse yourself, make sure that full table name as a alias, so that that table name would appear here, or have some meaningful name, so that when you look at this output, you will clearly know what is the table it is referring to. If you look at the partitions column, there is no partitions appearing here. Why? Because there is no partition created for any of the entities in this specific schema. But I'll just add a point here, which is explain statements can be executed on partitions as well, meaning it can consider the factor of partitions as well during the query performance analysis, right? I'll try to cover that as part of a separate tutorial, because I have to create the setup for that, which I haven't created in this case, because whatever I'm explaining is altogether a different related but different track, so I haven't covered that part. Moving to type, so it is like what kind of access type. It is all, meaning it's like full table scan. It is happening a referential scan. If yes, then partial key will be applied, which is known as non-unique key lookup. If it is EQRF, which is of course better than REF, so it's like equality operator kind of, it's like uh, exact match, and this access type will be unique lookup, right? What are the possible keys? So these are basically what are the keys available in your specific entity, so those keys would appear here. And again, what is the key type? It's a primary key or what, so that will appear here. Key length, so key length is basically whatever the primary key on a given entity you have defined, what is the length of that, that tells about this key length column, right? So if it is an integer, boolean, so for each of the data type the key length will be changing. Again, if that attribute is holding different types, so for example in this case product code is, let's say it's a what, so product code is basically varchar 15, right? So for that it has evaluated the key length as 17. But if you look at the customer number, it's a probably I think integer. Hence the key length will be integer. In case of full table scan or access type as all, definitely key length will be null. But I'll make some tweaking to show you where it will do the full index scan instead of full table scan, and in that case it will apply the order number as a uh, order number as a key, and it will make use of that, and for that key length will come as 4, right? And it will also show you what reference or where is the reference, right? Initially how many number of rows it is getting hit. So of course it is happening a full, it is doing a full table scan, and it's an entry point, so it has to iterate all the or extract all the rows or all the records, and hence it is showing like 100% filtered. It's like percentage. Again, this shows one, meaning uh, for one iteration what is the average number of row, or yeah, what is the number of rows it returns, right? And we have seen that in the diagram as well in the visual explain. So here for this case it is 1. For wherever you have the access type as EQREF, you can certainly say that your number of row will be 1. But in case of REF, it can be 1 or it can be like equal, greater than equals to 1, right? Filtered is basically how many rows are getting filtered from that specific entity or for that specific entity, right? So that is what your filtered column. Extra is basically either it is using indexing or not. So again, we will see that currently it is blank. We'll see what value is appearing in the extra column. Okay. I hope the explanation of tabular explain. Okay, I hope explanation of tabular explain of all these columns and its use cases it is clear. If you have any doubt, feel free to reach out to me. If not, then definitely it's very good. Initially, I was facing some challenges to understand each of these things, but once I started playing with this, I got familiar with all these terms, and it is definitely making more sense to me now, right? So now out of this discussion the two action item came out, right? First, to change the access type from all to index, and we will see if you make that change what value would appear in the extra column, right? So for that I would like to go to again switch to this query, and if you see this in the orders table, right, if you remember in the orders table we have only one primary key, right, which is created on the order number. And what we are trying to do here is we are trying to fetch the order date as well, which is not available in our index table space. So as soon as I comment this, right, you'll see the magic here. Okay. Now if I run this, of course in the output you'll not see the order date column, but when I run this query, I mean, when I execute the explain statement, if you look at the output, see, access type has changed from index, right? And key length is appearing as 4 because it's an integer type, integer data type. And then it is using index. So it is basically telling you what exactly it is doing. So it is saying, I'm going to use index. Instead of full table scan, I'm going to use index scan, right? Now let's switch to the visual explain and see the change uh, if it is reflecting over there. If you see, now it has changed from full table scan to full index scan. And it is making use of customer number because that is what we have available here, right? But overall in the costing, there is no much change. To summarize this specific segment of tabular explain, we have understood the term or concept of each of these columns, uh, like type, what is this table, what is the select type, key length, key, which key is basically getting applied, rows, why it is 1, 9, 326, why it is 100 under filtered, what is using index under extra column. We have gone through all those things. I'm hoping that I'm able to explain whatever I wanted to or intended to, and it makes sense as well. Uh, Again, having the concept or understanding of all these terms is very useful when we are optimizing a very complex query. Okay, this will give this understanding will give you a lot of inputs to ourselves in order to improvise the query performance. And with that note, I think we are good with the tabular explain. We have already seen the visual explain, so I'm not going to cover this.